Good morning, good evening. Thank you for joining the session. Let me quickly share my presentation. I hope you are able to see it. Play as well. Can you just confirm if you are able to see the presentation?
Yeah, we can see it.
Perfect. All right. So let us start the course. I welcome you guys to this course. Probably a couple of days. What we'll do is we'll do the basics of it. We'll understand the background of it. We'll deep dive into the course content. We'll see like how this is structured, so that everybody is on the same page, have the same understanding. And then from early next week, we will start Python for data science, which is very important topic. As a core language, we need to have a strong foundation on that. And then as we go deeper, we will delve into machine learning, we will delve into deep learning, then into generative AI and agentic AI. So that's how the course would be structured. So today's topic is basically to understand about, what are those different application areas which has contributed to the rise of artificial intelligence and data science in specific. The first one I would say are these social media analytics companies, the likes of Google's, Facebook, YouTube, LinkedIn, Twitter, Instagram. So all these companies, if you see, uh, traditionally the regular companies were using traditional data sources, mostly tables like Oracles, MySQLs, and so on. Most of our data was stored in traditional data sources, and analytics was more like a SQL-based analytics. But for these companies, the nature of data was different. For some companies, it was videos. For some company, it was some feeds, textual information, images, pictures. So the way in which the storage, compute, and analysis of data for these companies was different. And because of that, they have created a lot of uh, proprietary storage models, and also they have open source a lot of their storage systems, um, analytical systems, and different libraries and algorithms, because of which a lot of trend actually happened. I can say like 10 years back. If I go 10 years back, there's a lot of push towards how do we do big data analytics, how do we store large volumes of data, a large quantity of variety data, and so on. So there was a strong push in getting all those systems ready. Now, why do I talk about this is because if we look at the current moment, the companies who has invested in storing large volumes of unstructured data are reaping great benefits right now, because at that time they have stored images, they have stored images of images, videos, call logs, and all those information, and they didn't had a lot of technology to analyze those information. But nowadays, because there's a strong algorithmic availability, because there is a strong availability of compute, we are now able to reap the benefits. So I would first say like the social media kind of companies are the pioneers in which they have they have bought these technologies, they've got these technologies into the mainstream, and then eventually the other companies, traditional brick and mortar business companies, have adopted them. The companies which are reaping benefits, and early companies which used something called as predictive analytics. Now, one part of artificial intelligence is where we are trying to make computers do the work of humans. And one of the very commonly used use case is the predictive analytics. Now, given the past data, I wanted to predict what is going to happen in the future. Now, a lot of information I've collected a lot of data from the customers, products, sales information, leads, and all that stuff from the past. And then now I want to use that information to do some predictions in the future. For example, who will be the customers who are going to default my loan? Should I give this credit card to ABC customer or not? Right? Which are the products I'm going to bet upon, so that they will have they will have the greatest revenue for my company. So all these things have something called as predictive nature. That means that we do not know the answers right now, but we are trying to anticipate the answers which are going to happen in the future based on the past trends. So companies like banking, financials, insurance, some part of retail, they are the early adopters of predictive analytics. So when there's a large stream artificial intelligence, data science based workload started, predictive analytics took the first place. This is another important use case. Again, a lot of banking, financial, telecom, insurance related companies have adopted these use cases of artificial intelligence. Typically falls under something called as fraud and intruder detection. Now, fraud and intruder detection is very, very important, because as the businesses grow, there's a lot of fraudulent transactions, misleading informations, and similar kind of frauds happen. There can be banking frauds, frauds with respect to false claims, frauds with respect to uh, any of the telecom inclusions and things like that. All those things happen in the regular day-to-day life, and it is very important for these companies to identify those frauds well in advance or find out patterns in which they can detect the frauds. Many algorithms, typically in the case of anomaly detection, what they do is these anomaly detection try to identify transactions which are separate from the regular crowd. So imagine I groups thousands of transactions, then I can easily determine the transactions which follow a different pattern. Probably you're swiping your credit card in a different location than you're regularly using, or maybe you're doing a transactions which is much higher than your average transaction usage. So all these kind of things basically falls under something called as an anomaly. Now, all anomalies will not be frauds. So we need to have build a system in which we try to find out these anomalies and then feed it to either a system automated call, automated message system, or human in the loop. So all these companies, what we have done is like first determine these anomalies and then feed it into a right channel or a workflow in which further actions can be taken. Maybe when you do, you automatically get a call saying that, could you authorize this transaction, right? You might have already getting these calls, right? Or maybe you might get a message, or sometimes automatically the card gets blocked because we do see that this is a high fraud based transaction. The card gets blocked, and only after you authorize and release the card, then the transaction will go through. So, depending upon the severity of the problem, these kind of systems are built so that the customers are saved from all these kind of transactions. Another interesting case, especially in case of natural language processing, it's called a sentiment analysis. Look, a lot of retail companies, when this started, has adopted this. Sentiment analysis, we want to understand what is the customer thinking and how is the sentiment of the customer. I remember in early to 2010, I would say, I have built a system typically on this sentiment analysis. Now it's almost like what, 15 years back. But back in those days, the sentiment analysis was very, very raw in format. For example, I used to work for a large car rental company. It's a large car rental company in US, and pretty much what they wanted was they have these rental locations, like rental locations in JFK. You have in Fort Lauderdale, we have in Miami, in Los Angeles, and so on. So different locations, they have these car rental locations, and they wanted to understand the health of those rental locations based on the customer feedback. So they used to have a portal called as Voice of the Customer portal. And then once the rental check-in is done, the customer has checked back his car, then they were asked to feed in this natural language feedback, like how is the car, how is the service, how is the rental location, what is the comfort for the customer, and all that stuff. There are different parameters, and he has to write some feedback, and they used to call as Voice of the Customer portal. And in this Voice of the Customer portal, there's a lot of textual summaries which were provided, textual feedback, and then we have to analyze that based on the sentiment. And then based on the sentiment, we need to categorize the locations by zones, by states, and then categorize them into, say, like which are the good locations, which are the bad locations, Also, in bad locations, what are the feedbacks and the areas of improvements and so on. Now, to do that work, we had a huge project, and because it was pure play natural language, you have to understand the natural language, you have to understand the utterances, you have to identify the keywords which provide the sentiment. For example, awesome is like very, very positive sentiment. At the same time, untidy, awful, and so on are providing negative sentiment. Now, the work used to happen in such a way that we need to have screen through all the sentiment, all the textual feedback, and then get that information, which is very, very tedious in nature. Now, fast forward right now, we are seeing that using the large language models. Now, don't worry about what are these large language models, what is the generative AI, and all that stuff. We'll go deeper into it, but just understand the context that now, given the current situation, we do not have to do any such codes. We have functions, we have direct usage of the functions. We can directly invoke one of the large language model either on-prem or or on a cloud, and then can invoke these sentiments. Now, the sentiments we don't just have to have a positive, negative kind of a thing, but we can also do sentiments as close to. Just a second. There's some message. Somehow I'm not able to see it. Okay, can't hear. Are you able to hear me, guys?
Yeah, we can.
Okay, apologies.
వచ్చేసాక ఇండికేటర్ అయిపోతే ఎట్టా నువ్వు వెనక
You can go on mute.
వెనకాల నాకు కనిపించలేదు అప్పుడు లాస్ట్
Yeah, somehow my screen was frozen. So, okay. So what I was saying is currently now we are in the situation where we don't have to do any hard coding. So you don't have to write systems to understand utterances, the meaning of the sentence, the 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 nature of the sentence, the structure, positivity, negativity, sentiment, and all that stuff we don't have to do. We just have to feed the applications because we have large language models who are capable enough to identify this, and we can also do something called as entity resolution. We try to identify which parts of the sentiments over large volumes of sentiments of reviews, what are the top 5 problems. If I can ask the large language model, it can condense all this information and then provide me the aggregated top 5 problems of a product. It can also provide me the good things, the bad things, and the things to improve. All that stuff, it is easily possible right now. Self-driving cars, again, this is another interesting technology in the last decade. We have seen that a lot of cars are roaming around, and it is only possible because of the artificial intelligence, which is playing a large role, right? So there are a lot of these sensors and camera, gyroscope based feeds which will go into the car, and based on the automatic systems which are developed in the car, it can determine a lot of things. For example, how far is the object, should it take a brake or should it take a acceleration. So a lot of these signals are guided by these sensors. Now, while we'll not be doing a lot of project on this, but if you were able to understand that the world is going in a pace in which the AI adoption is in every field. We will see it in healthcare, we will see it in retail, movie domain, video industry, car industry, and so on. So every industry is having this particular application. Classification and clustering. So these are one of the algorithms which we generally use in data science, that classification and clustering applications. We will go deeper when we are learning about machine learning, to understand what these algorithms are and how we can practically use in our day-to-day applications. Now, classification talks about identifying categories in which a particular data belongs to. Suppose I wanted to identify high net worth customers, low net worth customers, and medium net worth customers. Imagine given a lot of transactions they do, I need to identify that. So this is falls under classification. Imagine you wanted to identify emails as fraudulent, spam or non-spam. So this is a example of classification. Now the clustering is another similar kind of algorithm grouping where we try to identify data points and then find patterns in that and then group them accordingly. While classification, we have a proper output group where we can tag to, but clustering does not have a proper output group. We will basically see all the patterns of the data and then group them accordingly. That is clustering. Another interesting use case is recommender systems or recommendation engines. And we see that a lot of applications are there where the recommendation engine is being used. It can be your Netflix, which recommends you the next best movie to watch, or it can be your Amazon, which is trying to identify that because you have bought this product, this is another product which is very very suitable for you because people who bought this product also like this product. So when we are seeing this kind of associations, we are trying to find out something called as association rule mining, where we are trying to find out associations between the product, and there is a strong associations between the product, then we use that association to recommend to future customers. It can be a sect of customers which are similar with similar patterns, similar likings, and so on, so that the products can be easily recommended. This is very well used in something called as cross-sell, upsell conditions. So you're trying to have one product, you would like to sell some other product because there is a strong association between them. So a lot of companies are using this. We now use it in most of the companies, and recommendation becomes one of the primary model driven, which can generate a lot of revenue for companies. Another interesting use case is in transportation, car sharing industry, especially like companies like Uber, Lyft, and so on. So as we see, AI is kind of used in all these industries. Now, the way Uber has used AI is trying to identify two core important things of the way in which it is doing the taxi business. The first one is basically like how do we identify customers and where where will be my customer, where will be my next customer, right? So this is important because my Uber driver does not need to just drive through the city praying for his next customer. So because of the data, Uber has a lot of data points. We can identify that. Based on the data points, we can aggregate and see like where will be my next transactions. If you see, most of these transactions are trend in nature. For example, every day morning 9 o'clock, or say morning 8 o'clock to 9 o'clock, there will be flow of traffic from one area to another area. So you would need cabs to be available in the area one, so that there will be this flow can be identified. Maybe in every evening, say like 5 o'clock to say 6 o'clock, there will be an area where there are a lot of offices and there will be a lot of lean of cabs. So looking at the past aggregated data, you can clearly apply algorithms in which it can determine and pinpoint even locations or what we call as hotspots where the customers are available and there is a quite a large probability of getting the bookings done. Similarly, we also see the search pricing where it is trying to identify the same patterns like number of bookings, the location, the time, and all that stuff, and then try to put surging on your pricing. Because there is a lot of demand, it is quite obvious that these the drivers, the Uber company would reap benefit out of it, and if they can put surge prices, then people who really need a cab, they are also willing to pay higher prices for that, and that's the way the company is making a lot of profit. This is one interesting application. In early years of this application, we have worked on it, where we are trying to find out um, human emotions, and human emotions basically will help these automated robots. And I am very positive that in the coming few years, 2 to 3 years, we would see a lot of companies having these automated robots, whether they can be delivery agents, they can be customer service agents, and so on, which basically interact with humans. Now, when we are interacting with humans, we also need to understand not just the voice, tone, and the basics of the communication, but we also need to understand the facial expressions. Now, is the person happy? Is the person sad? Is he angry? So all these different natures are important. Is basically from facial expressions it will be able to understand. Now, humans are really intelligent in this area, right? They can understand this. Based on that, they can also quickly turn tables and then do some other actions which are necessary for that particular situation. While if I have an automated robot, the robot will not be able to do the same job properly. Now, there is a lot of research happening in this particular space to identify, human emotions, uh, trying to determine the human emotions combined with, tonality, combined with voice modularity, and all that stuff, and then based on that, determine the situation. Now, once that is determined, suppose you created a customer service bot and it can understand who is an angry customer, and then based on the current situation, it can give some suggestions, right? Or maybe take the customer to a real human agent, right? Because the bot can't handle it. So these things are coming up, and we are very fortunate to see a lot of technological changes. We have seen internet, we have seen mobile revolution, we are seeing the adoption of AI. ChatGPT has come, and sky's the limit. In the coming few years, we will be seeing that there will be a lot of these kind of automated bots, which will be of our help. One other interesting use case, again, this is a very, very important use case. I worked for one of the large pharma client, and that client basically wanted to use this kind of drug discovery patterns. So drug discovery is a very large, tedious process. I want to release a drug, then it has to go through a lot of testing cycles. So you can't directly take the drug out of into the market and use it on humans because it is very dangerous. There will be a lot of lawsuits and so on. So the traditional pharma industry, the drug discovery cycles are very, very long. They have to go through tedious test processes, and there are FDA authorities and all that stuff who will get into the testing part of it and then ensure whether the drug is properly tested or not. And only then it will be released to the larger audience. Now, this is really important because if my testing time is not cut, then the availability of drug will take a lot of time. If you have seen a lot older vaccines, you used to take a lot of time to come to market because they were going through these rigorous testing cycles. And COVID is one example which actually cut down a lot of testing time because it has adopted artificial intelligence. And the way in which it can identify testing patterns, the way it can simulate you know, it can simulate the efficacy of the drug. All those things were tested, and because of which the drug discovery time was cut. And nowadays, there are a lot of companies, pharma companies, which are working on this particular clinical examples. AstraZeneca is one of the leading company which is doing that kind of analysis, where where we're trying to identify that how do we cut down this drug discovery time, testing cycles, so that you can use data science AI for cutting down that time and ship the drug much faster. Internet of Things. Now, this was my favorite, was and also is. Um, this was my favorite area of application of AI. Uh, Internet of Things, as you already know, it is like how do we see that internet is connected to all the devices around us, and then they can transmit data. You and we can use the data for doing a lot of data processing and so on. Now, this is an example of a large shop floor. This is a car manufacturing company. And basically, what it does is it does the assembly of the car chassis, and it does the assembly of the car and all that stuff. So imagine it's a large car manufacturing company in US, and it is doing all this, assembly line. And and what it did is, like, all the machines which are operating on this assembly line, they have, instead of manual supervisors who go and look at the health of the machine, they have installed a lot of chips and a lot of devices which can measure, for example, what is the temperature of the machine, what is the viscosity of the lubricant fluid, what is the turbulence of the cutting lathe, and so on. So all these devices were installed, and these basically sensors try to determine all this information and can feed this information to a central hub. Now, there are different machines working in tandem, so you will get this information from all the machines, and then using data analysis, we can then determine that which machine is in bad shape, which machine can go, can is in the burnout stage, or basically it will go bad in couple of days. Maybe some machines would require some replacement parts. Maybe the cutting lathe has to be changed, or lubricant fluid has to be recycled, and things like that. Typically, a supervisor used to be doing all these checks. There are a lot of supervisors who are on the shop floor, and they used to monitor these machines, and based on their human knowledge, they used to take decisions like, okay, change the lubricant fluid, turn off the machine, or change the specific part, and so on. But because now using of Internet of Things, using of sensors, using of artificial intelligence, now the supervisors, we don't have to rely on the supervisors, because the algorithms can clearly say that which machine is going to go bad in the coming few days, or which part needs to be replaced. So we can go to that level because we have a lot of data backed up, a lot of information is already available, and using the data we can identify patterns, and we can use one of the machine learning algorithms to determine the machine which will go bad, and even we can determine which part has to be replaced, right? So a lot of manufacturing companies are using this. The project which we do this is called as preventive maintenance. So preventive maintenance of shop floor, this is a project, and it basically determines all these patterns and then can feed the information. And the supervisors, even there will be human in the loop. It is not like we completely eliminate supervisors. There will be human in the loop. We will decide the decisions, and we will feed that information to supervisor, and supervisor, using his personal knowledge, will actually go to the machine, determine the correctness, and then take some actions. So Google Assistants, Siri, Alexa, all these things, you're quite familiar now. A lot of algorithms are coming. Now we are also seeing the bots equipped with ChatGPT like applications now where we can ask questions, it can understand language, it can convert the language voice into text, um, text to query, and then can query certain information and then come back. So all this technology is again fully backed up with a lot of models. One other important area is healthcare. Now, healthcare is quite essential because this is like a bloodline for the entire human species, right? We certainly need this healthcare, and and if we can improve the efficiency of healthcare, try to identify how technology can be used for getting into something called as personalized medicine, right? So that will help a lot. Now, where do we use this kind of technology is basically because we have a lot of data, and we also discussed about something called as clustering. So imagine I cluster different patients into different groups, for example, based on their blood tests, their vital elements, and age, gender, and different other parameters, right? Is the person fat? Is the person thin? Is the person having any uh, deficiencies? Is the person diabetic? Having any heart problems? So there are a lot of these parameters, and based on all these parameters, we can cluster patients into different groups. And once we do this clustering, then we can determine exactly the type and nature of patients on which a certain drugs are working and certain drugs are not working. So we can go to something called as personalized medicine. Imagine I identify a patient who is like 75 years old, who is fat, who is having mild heart-based disease. He is diabetic, and his lifestyle is a regular basic lifestyle, doesn't do any great workouts or anything. So given all these parameters, can we determine if the same patient can be given a similar drug, right? So based on the past information, the hospitals have something called as electronic medical records, EMRs we call. Electronic medical records are being used in hospitals, especially in the West. They use a lot of these EMRs to track the patient history over time. And we have a lot of these patient histories, and based on these patient histories, we have also known like which drugs were used, which drugs were effective, and what were the recommended drugs, and so on, or recommended uh, therapies and treatments. So all those things are readily available, and given a new patient comes, we can use the vast amount of information which doctors already have in the form of EMRs, and use that information to treat new patients. So it will assist doctors. It doesn't completely replace doctors because that will be very scary, but it assists the doctors, saying that, okay, given these conditions, proven these methods, I think this one will be a suitable option, and so on. So that way, a lot of research is happening in the space of healthcare as well. So all this is good. So we are understanding that, okay, there are a lot of applications in media space. We have recommendation engines, retail, banking, healthcare. Okay, all this is good, Sitaram, but how does this entire thing works? Now, what is the base of this AI models? How do the model works? How does the data get collected? What is happening? All that stuff. So let us have a sneak peek of how this entire machine learning process works. So on the left side is like there are data providers. Now that can be internal systems. Like there can be sales system, marketing system, your customer system, which feeds all this information, or it can be external data providers which can plugged in. For example, things like Equifax and so on, Experian. So all these guys basically feed external informations. There are research agencies, the likes of EY, KPMG, um, and different agencies which can feed information to us, and then we can use that information for doing some analysis. Now, the first stage is where we store a lot of these large volumes of data. We call this as ingestion. Ingestion in which you feed all this data into a large volume of raw storage. And there can be multiple layers of these ingestion. So you can say like T1, T2, T3 layers, tier 1, tier 2, tier 3s. So tier 1 becomes your raw data, and then that can go to another tier which does something called as data processing, where you can say like I can combine couple of tables and create more of a structured data, right? So once we have raw data where I can call it as a tier 1 data, you could create some applications which does a lot of data pre-processing. And the data pre-processing is done where you can drop some tables, drop some columns, remove some records, clean some processing, do some analysis with respect to missing values, NAs, and so on. And all that is done, then you turn the data into a structured format. Now, once we have a proper structured data, which is in the middle, the green one, then we have a suite of algorithms. Now, again, the machine learning is a very wide area where we have a lot of machine learning algorithms. Within one set of algorithms, we have plenty of them. For example, classification itself, we have a lot of algorithms. Now, from these algorithms, which one to choose, right? It becomes very important to understand that from the suite of algorithms, which one to use, which one will perform better, and all that stuff. So for that, we do a lot of experimentation. Now, that's where the experimentation stage happens. So you generally, depending upon the company, we will generally have, say, like two different clusters. There is like a test cluster or an analytical cluster, where a lot of data scientists will be doing experiments. They will try to create, try and test different models. So we have applications like MLflow, where we can use MLflow for trying and testing different models. So imagine I test 5 models, and out of the 5 model, the machine learning model, algorithm, say like using XGBoost, it is performing really well. Then I will finalize that model. So we call it as a candidate model. Okay, it might be at a very high level. I'm using a lot of terms, but please bear with me that as we go slowly, we will delve into each and every concept. But for now, just understand that the raw data is fed, then there is some system which is processing the data, making the data available in a clean and nice format. Once my data is available, then I have a bunch of algorithms, and I have this ability to test all these algorithms. I'm using some tools like MLflow, and I'm logging all my experimental data. I have my ability to search through multiple models, identify which model is the best performing with respect to all the parameters. Then I can select that model and I can call it as a candidate model. Once I select my model, then it comes the deployment stage where I have to use some packages. I might have to use things like Jenkins and so on, where I can deploy this model as an executable. There are two phases. We will cover this entire section in very deep detail tomorrow. I will talk about how the flow happens, and we will basically then deploy the model, and applications will be using that model for doing some predictions, either in an online mode or in a batch mode, right? So this is the general flow. Similarly, we also use these large language models typically backed up with neural networks. So this is a simple example of a neural network, how it works. Now we are seeing large volumes of unstructured data, textual data, image data, video data. Now using that information, we are trying to look at a lot of possibilities. Like, given an image, how do we identify whether it is a particular image or not? This is required. For example, I'm creating an application, uh, looking at information, it can take some decisions, right? So that that is what this application does. But this is how the traditional neural network looks like. We feed input information into something called as input layers. Then we have bunch of hidden layers where a lot of processing happens, and then we have output layers where we come up with some kind of a classified output. So this is in more detail, like how this feed-forward network looks like. The reason why we are learning all these things, like, so the number of jobs of course, the date, it's a very old data, but the number of jobs have increased a lot in the space of AI, machine learning. Again, the segments of the jobs are also increased. So we are seeing that within data science, we have different jobs. We have data scientists, senior data scientists, junior data scientists, data analyst. Then we have machine learning engineers. Then we have prompt engineers. Then we have generative AI developers. So the number of job opportunities have increased over the time, and then we are seeing this is going to grow in the future. There is also a lot of job opportunities both for uh, junior folks, mid-level folks, and also for senior folks. So this is quite an important time in which where we can equip ourselves with required knowledge and then can tap the opportunities. I think in my first session, somebody was asking like, how do I get into these opportunities? So I was talking about that our sessions will take around 2 months. But during this 2 months, not only understanding the technology, but we also need to parallelly do some kind of research work. So depending upon which area you are in, you need to understand what are the companies which are within your purview, how many jobs are there, what are the jobs which are suitable. For example, there can be a requirement for machine learning engineers, there can be requirement for junior data scientists, and so on. So depending upon what type of jobs are there, which companies are there, and what will be the pay scales, required skills, and so on, and depending upon your current state, right? So what are you already currently? So you can be a junior engineer, or you can be a mid-level, or maybe a project manager. Depending upon where you are in this entire spectrum, you need to then pivot accordingly and take some certain steps. So I would seriously urge that you start doing that analysis right from the day one, because we need to cater according to your personal needs. It's not like one size fit all solution. While the course will help you to understand the length, breadth, and depth of the subject, but it is very important for you to do that analysis right from the start, so that we can exactly pitch in to the required jobs. Okay. And I will also help you to understand, like, given a specific your personal use case, right? Like, I am so and so experienced, I have so and so skill sets, and so on, but where do I fit in? Then we can do a very curated maybe a one-on-one kind of discussion, which will help you to uh, get into the required jobs which you are opting for. All right, so this is a very, very brief description about the skill sets. Like, what do we need? You would require some of the hacking skills, in sense the developer skill sets. So it requires, programming skills. You require understanding of how do I use specific libraries? How do I create models? How do I store them? How do I create deployable pipelines using Jenkins and all that stuff? So that becomes the hacking skills. The math and statistics knowledge, it's about the core mathematical concepts which are required, statistical knowledge which is required to build models and so on. And subject matter expertise, it depends. For example, you have core expertise in, say, pharma, you have core expertise in banking or in retail. All that together, coming together, you would create the skill of data science. So it depends upon which area you are in. You will be able to club all these things together. You might be at a junior level. You have a lot of hacking skills or developer skills. You do not need to have a lot of subject expertise. It is still okay. But if you are a senior person or into the senior role, you will have more of subject expertise. You might not need to do development, but you can you can give directions to the team, like what need to be done. So once you are equipped with all the underlying technology, you will be able to give proper directions. All right, so with that, I would like to close the sessions. If you have any questions, please do let me know. I'll be happy to take few questions.
After taking AI course and after kind of being proficient, being a gem in this AI, so is it we will be working as a data scientist in future?
Yes, so there are different roles, as I said, right? So data scientist is pure play working on algorithms, trying to create new applications fitting into the business domain. There is also like ML engineers, ML ops engineers. So they are more ops guys, right? So for example, they don't have to build models, but they need to know like how do they productionize the models. So depending upon, so that is like the DevOps side of it. So depending upon the area of expertise we have, I will recommend people to get into different type of roles. Imagine I am very comfortable with, say, like DevOps side of it, like say Jenkins, Kubernetes, creating pipelines and things like that. Then getting into a machine learning engineering role will be very comfortable, right? Tomorrow I'll talk about that, who can be coming from what previous expertise and what will be the best entry point for different kind of skill sets. Okay, tomorrow I'll talk more detail into it. But to answer, depending upon your skill set, you can either get as a data scientist or a machine learning engineer or a generative AI developer.
Okay, thank you.
Okay, I see a question. So the question is, what is the difference between neural machine translation like Google Translate and LLMs, especially when it comes to language interpretation? Both are same with respect to the capabilities. Neural machine translation, now this gets more technical, but neural machine translation is focused on language translation. So we have one language to another language conversion. That is what it does. But underlying technology is same. It still uses the neural networks. Both the LLMs and neural machine translation use the same technology. The only thing that LLMs are trained on a much larger data, and it is capable of doing a lot of things, not just machine translation, but it is also able to do, say, like summarization. It is also able to do context creation, question answering abilities, and all that stuff, right? So you could say like a neural machine translation is a subset of what LLMs can do.
Yeah, so Sitaram, the reason why I'm asking is it's not something new, right? The NMTs were there even long time back, right?
Yeah.
This is not something new. So why LLMs all of a sudden catching the buzzword?
Yeah, the reasoning is neural machine translations were very, very specific, right? So the way their requirement was very specific. What LLMs has created, the buzz, the reason it is created is like the possibilities of using them has become huge, right? For example, I can create my entire customer journey, right? The call center customer journey is disrupted now because I don't need a customer agent to do a talking to the customer, understand the query, give suggestions and all. So if you can look at that workflow of call center agent, that entire customer journey is broken into multiple pieces, and LLMs are able to take large chunk of those pieces. If I want to convert my call speech into text, they're able to do. Once the text is converted, if I want to summarize the text, LLM is able to do. Once the text is summarized, if I want to recommend some products, LLM is able to do. Right. So that's where the agentic is coming again. So
Yeah.
as an example, right now, the way the LLMs, the capabilities are quite large, and they're able to do a lot more things easily. And because of the chat GPTs and likes of the models, everyone is now equipped with them, and they're able to understand what are the capabilities of that. And businesses are now forced, I would say, forced to see visualize use cases where they can make benefits of these LLMs and induce them into their key products. That's what is happening right now. But that's what NMT, neural machine, is very, very focused area, where LLMs are more generalized, right? So that's what is the answer.
So in other way, like the intelligence is added to NMTs, so which probably made LLMs, right? So because LLMs doesn't have the intelligence, LLMs have the intelligence.
LLMs, yeah, what I would say is both are same at certain level. NMTs are basically focused on specific thing. LLMs are much broader, right? More intelligence, you can say. Large volumes of data is there. It can do a lot of things now. So that is the core difference.
Okay, thanks.
All right. So which will be a suitable for an QA automation engineer who know coding? So yeah, so I was saying, because QA automation engineer, you will be familiar with a lot of these pipelines and all. The good job role for them is machine learning engineer. In fact, there is also a role called as machine learning tester, MLT. Machine learning testers, even my team has MLTs, where their core purpose is to test the entire data science ML pipelines, right? So automate them and do the testing. So if you find those roles, then it will be the first entry point, very easy entry point, and then eventually you can grow through the data science side and work in that area.
And to automate that ML pipelines, again, we should use an automation language like Selenium or anything.
Yeah, it's the same, right? So instead of application, we are automating a model, right? So they use Selenium.
Eggplant, yeah.
Yeah, so we have like a basic the ability to create pipelines, the ability to create test plans, execute the test plans, Gherkin scripts, and so on. Frameworks like TDD, BDD. So those are the ones, same ones are used, but a core product is different. Any other questions? Did I miss any question? Let me check. Any other questions, guys?
So, Siddharam, this is Arun Macha. So, just one question.
Mhm.
Do we need to have any prerequisites to learn the course? No.
Python language is something is a prerequisite.
Mhm.
Or any programming language, you need to have some programming background, right? So that you can appreciate the course much faster. We have a section Python for data science, which will be talking about how do we use the language for creating models, doing data transformation, understanding the libraries which are commonly used. So that section is there. But if somebody is
Okay.
already familiar with any programming language, it becomes easy for them to grasp those concepts and then run them.
Okay. Sounds good.
Okay, so the question is, okay, manual tester with databases and math and coding knowledge. The manual tester, see, answer is yes, uh, but they need to have familiarity with some kind of tooling, right? So some kind of, I'm not saying automation tooling, but familiarity with say like pipelines, familiarity with say like DevOps tooling and things like that. If that understanding is there, then getting into ML engineer role is easier for a manual tester. Okay.
Sitaram, will we be dividing this particular team into multiple groups, because based on the experience or based on the level of expertise, or is it all going to be run as one group?
For the training part, because the training part is like a generic one, so it doesn't. If I do the division, then what happens is like we will run multiple cohorts and doing that. What I generally do is people who have that expertise, right? So I imagine I am already experienced in certain background, and they do sessions with me one-on-one, maybe, or like a group. So where we will cater to the exact needs for those particular group of users, right? But from a training standpoint, it will be given for the entire group, right? It's very difficult for me to do that kind of catering because pretty much most of that would be generic. Uh, it is it is primarily looked into technology oriented roles only, because we are expected to do code. So because now only for few days I'll be going through these presentations, but from next week onwards we'll be just directly jumping into the code. I'll be talking about how do we install Python, how do we create our development environment, how do we write code, how do you use libraries. So it will be primarily coding only. So it will be expected that we get our hands dirty. So as and when we go, we will see that. But for now, the answer is no. So as and when we go deeper, we will see like how much customization is required and things like that. All right. Okay. Any other question?
Yeah, I just have one other question, Arun. So in the broader way, right? In broader aspect, so AI is huge now, right? I mean, AI has so many branches, and we have the machine learning and then deep learning, neural networks. Now we're talking about generative AI, LLMs. But the new thing came up like agents, right?
Yeah.
Can you give us some kind of a diagrammatic representation of the life cycle of this AI?
Yeah. The tomorrow session will be that.
Okay.
It will
Okay.
require me to spend almost like 30 minutes to just
Okay,
talk.
sounds good. Okay.
So next few days we'll be talking on that only.
Awesome. Thank you so much.
Right. So for a middleware WebSphere admin, what would be the suitable role. So I can't again talk about every role, but I'm saying like people who have experience on the DevOps angle side of it. Again, please come to tomorrow's session, okay? Because I'll be talking on that. I'll be talking about the entire ecosystem space, and then I'll also give these directions on which particular role uh, will be suitable for what will be the entry point. Okay, there are different entry points for this entire AI space, right? Somebody who's already an admin, or like say infrastructure admin, database admin, uh, for those there is a different entry point. For somebody who is already a full stack developer, right? So I'm already doing my Java, Angular, that kind of a skill set. Like, what will be my entry point? Somebody who's already a DevOps kind of a person, already familiar with, say, Kubernetes, Jenkins, some kind of pipelines, and what will be their entry point. So there are different entry points actually. It depends. It's not one size fit all. So tomorrow we'll discuss that in detail. Okay, someone is having IT management, information technology master's degree. I think so. I to discuss more detail, Shanmukh. So I'll not be able to directly tell where it will be used, but because if you have done IT, then the sky's the limit. You can get into multiple roles. Recommended role will be a junior data scientist or machine learning engineer or a data analyst role. So those are entry level roles. You will be able to get into those entry level roles, and eventually you'll grow.
Yep. Thank you.
The course cover ML development life cycle, like data prep, model development. Absolutely, that's what, Jay. So this is what we're going to cover. So we'll do the data preparation, model development. We'll understand the tools required for model development, and then we'll understand the tools required for model deployment. And especially, we will pick up cloud. We will either use AWS or GCP. We'll see how do we deploy models onto those clouds. Use some of the native cloud solutions. Do a contrast between doing an on-prem deployment and a cloud deployment. So as and when we go deeper, this is what you're going to experience.
Where's the other guy? He's done.
Okay. Any other questions, guys? Okay, a little above the time. Generally, we will take around 50 minutes for the course content. Then I'll allocate like 10 minutes, 5 to 10 minutes for our questionnaire. Generally, the first few sessions we will have more questions so that it will go a little above the time. But eventually, as the course progresses, we will be just condensing the time into an 1 hour session. Okay. So I'll be here for a few more minutes. If you have any questions, just let me know, or else you can drop off. I appreciate for your patience, and thank you very much for coming. Continue coming for next few days if you wanted to understand more details, because next few more days we'll deep dive into more areas of understanding, and eventually from next week onwards we'll start Python for data science.
Sitaram, since you said you are here for a few more minutes, I have a question. I know eventually you're going to cover it. I'll ask. So again, I'm referring to the course I did with you last time, a couple of years back. At that time, I think the course and what everyone was doing was collecting data, cleansing, preparing, just like you shown that PowerPoint slide just now, right? Everyone was cooking their own warehouses, lakes, and using that data to train, test and train AI models, and then using that model to serve the APIs and such. My question is, now given this ChatGPT and APIs available for ChatGPT, will that collection of data, cleansing, cooking things in-house go away and everyone is gonna just use APIs for the ChatGPT, or the need of in-house warehouses, lakes will still be there?
Yeah, to answer, basically, usage of LLMs and generative AI is very specific. There's a separate section in which they are meant for. Understanding of that is important now because, when we did the old course, classical machine learning, I call classical machine learning was very prevalent, right? Where people were trying to use machine learning, build models, and so on. So that is still there. In our course, we will still do that because 80% of the businesses are coming from that itself. So if you ask me where is the ROI, that's where from the classical machine learning.
Okay.
But when that is said, we can't ignore the latest trend, right? So the latest trends and how do I utilize the large language models, the OpenAI kinds of things? How do I create applications for that? How do I say like create agents? Now, agentic AI is new, and this year we are going to be the year of agents. So agentic AI is new. So as and when we are doing experiments within my company, I'll try to explain like what we are trying to do and how we build agents using LLMs and so on, which is going to be the future, right? So it could be somebody will be rolling out a course of agentic AI in the coming months, but that we will go and do firsthand. To answer your question, we will still have to have an understanding of traditional machine learning, classical machine learning. Somebody was asking questions, so will we go through the data prep, model preparation, and other stuff? We will still go through it. So for you, it will be kind of a refresher, maybe, but we will not learn every model. I think probably we will spend understanding of models, use the best ones, and go forward. That is my current strategy because there's a lot of depth to cover. Because generative AI is there, we have a lot of MLOps based things are there. Cloud adoption has improved. Now we need to have more focus on the DevOps angle of it, cloud angle of it. So I think focus will be more on application side of it rather than me spending 10-15 days on understanding different algorithms, right? I don't want to spend so much time understanding algorithm 1, 2, 3, 4, and so on, because given one recipe, it will be replicable. But what I will also do is probably record some videos on different algorithms and different this ones, and then we can provide that as an additional material. So that is something I will try to do. So that's the plan. I think as we go deeper, right, we will do that.
Okay, understood. Thank you. I appreciate that.
Great. Okay, so Kavita, I think probably we can have a one-on-one discussion. If you don't have experience in IT, if you have coding knowledge, right? And depending upon your career gap, we need to see like, what is your previous experience and then how you can fit into and which market you are catering and all. So it requires a little discussion. Okay. So maybe based on that, I can suggest.
I had a quick question. My name is Ritu. I am currently working on chatbot implementation, but the vendor does all the implementation, like the development and all that. So I am a business analyst. I do gather requirement, pass it on to the vendors. We sit with them, we sit with business. I do the documentation, we do testing, everything. But then like it's kind of a black box for us as clients to them.
Mm.
So I wanted to understand more of how it actually works.
I
I
would
also
say
want to
you are
understand.
already in a very better position, right? So imagine you want to become head of data science, right? You
Mhm.
don't just want to be a BA in after 5 years or 2 years, right? So
Mhm.
you want to aspire for that role, then you need to understand more of nuances like, okay, what is that black box? If I open the black box, what would I see? And then how do I direct
Mhm.
my team to do something? It can be vendor, it can be your own team, or mix of both, right? So
Mhm.
this course will help you understand those nuances, right? And then if your thought process is to become more of a head of data science or head of AI or something like that, that roles, then this will help you, right? So evolve beyond the BA role and then be a head of product or kind of things, right? There are a lot of companies which cater these roles, and pure business knowledge is very, very essential for them. They don't have to sit and code, but they need to tell like
Mhm.
what to do and how the
Right.
product, how AI will fit into the product, and how which type of models to use, how do I bring ROI. So that is a business side of it, right? But understanding of the knowledge, understanding the black box, and then directing the team to do certain
Mhm.
work. So that is a skill which those guys are required. Head of product, head of AI, head of data science, right? So if aspirations is towards that, then this course will help you.
Okay. And yeah, as I mentioned, like my contract is actually ending in 3 months. So I thought maybe I'll just like learn AI, like take some AI course for a month and probably start applying after that. Even the company I'm currently working for, um, they are actually planning on bringing everything in house. Currently, they're working with the vendors, but then like they want to do everything in house eventually. Um, so I think like having some knowledge of like what they're doing would be helpful for me. And yeah, I just wanted to understand how this course can help me in like which way.
Yeah,
But
but you need to do some code part of also, right? While
okay.
while I'm not expecting you to be completely proficient, write codes and all, but when I walk through the codes and all, you should have that open eyes to
Mhm.
basically appreciate it. If you have any problems, we will be able to let you know, because there will be more people like you who will have problems. There will be some sessions which will be very catered for them to do
Mhm.
more hand holding. But again, you need to look from that your experience angle. Okay, so the course,
Mhm.
uh,
Yeah.
and that's what I was saying. Like, given everyone's experience and everyone's background, you need to find out where you want to end up, right? Is it 3 months
Mhm.
down the line, 6 months down the line, 1 year down the line? But you need to have that roadmap perfectly planned so that it will completely align with what you're doing with this course. If you don't have that planning, please don't come to this course itself, because it's pure waste of your time, my time, everybody's time, right?
Yeah, I mean, like even for us to plan, we have to have some kind of knowledge as to, okay, like what would be the options?
Yeah.
Um, what can I learn? Where could it take me? Kind of things, right?
And this will give you that base ground, okay? And beyond that, you could build on that ground.
Okay. I have one last question. So, is this the timing that's gonna be there every day, like for all the sessions, or like do you have a different timing as well? Because this is kind of like prime time, especially like now I have 2 kids, uh, uh, so it's like hard for me to join every day at this time. This is like kind of their dinner time, bedtime, and all that.
Now this is a lot of juggling is done to find out the sweet spot. So I think because many people, again, people are from all over the world who are coming to the session, and different time zones also. So this looks to be the sweet time. I understand that you have to juggle with kids and all. And somebody asked in the previous session also to change the time, but looks like this is the most suitable time If you miss any session, there will be recordings provided, so you could go through it. But I would recommend if you can adjust some.
Yeah, I mean, like it looks like I would miss every other session. If this is going to be the timing, so is it like 90 minutes or like 2 hours? What
No,
is
no,
it?
no. This is not 2 hours. That's what today, as I'm saying, couple of days will be that. That
Okay.
will be for maximum will be for 1 hour. Okay.
Oh, okay.
Today it extended. I'm still waiting so that if people have some doubts, questions, so I'll answer them. But
Got it.
not
Okay.
necessarily everybody have to wait.
I think
Okay.
the
So it's 1 hour.
yeah, and I think timing will change from next unless you're in a daylight saving in Eastern. I think for Eastern folks at least it will become 9:30 p.m. next week onward.
Oh, I'm in Central, so it becomes probably 8:30 to 9:30.
Yeah.
Yeah. Yeah. Okay. Yeah. I mean, like, if you're like going to split into batches, if there is going to be a different time, that would be great. But please do think about it.
Sure.
I mean, yeah. I mean, like late in the night, early in the morning, either could work for me. If something could work. Thank you so much.
Thank you.
Yeah, hi Sitaram, this is Vidya. I have just a generic question. I work for the government sector in US. So most of right. So like the Fed space is not like completely AI driven. So they
Yeah.
are shifting. There are a lot of legacy applications they are trying to decommission, and they might migrate some of the new systems towards the AI just to downsize the workforce as such. So how easy, how flexible it is to ramp up to the AI driven structure? Like all the projects, because our legacy project is mostly on the Pega development side. So I just wanted to, that's the reason I'm joining. And I just wanted to understand how things can be driven so quickly, and they wanted to automate everything and use the AI. I mean, and in private sector, I can understand, but in the Fed space, there are a lot of guardrails that needs to be followed in terms of the PII data. So I just
Yeah.
wanted to understand your perspective. Is it that flexible, like how they anticipate? Because there are pros and cons, right? So you have to think from the cybersecurity standpoint as well, correct? So
Yeah.
just could you please just give me a glimpse of? I just don't need a lot of information. I'm just like curious. How can that be that easy or feasible? Like they can just like they're just comparing apples to apples, like from Fed space to the private space, but that's not that easy, right? So just wanted to get your opinion on that.
See, I think the first thing is the people have the intent. So whether it is government space or Fed or other organizations, they have a pure intent of adopting to AI. That intent is crystal clear, right? The only challenges are like, as you rightly said, that how do we quickly move from an old legacy to something new, or can we have a separate sideline where we can do something like POCs, adopt certain new technologies, and so on, and also
Right.
considering the PII part of it and things part of it. So I also work for a large banking corporation. So we also have similar constraints. We can't use open LLMs and open AI models.
Right.
So we have
Yeah.
pretty much in-house. So we do a lot of in-house thing, but for that also it requires some kind of investment, some kind of local
Right.
infrastructure, and so on. And most
Yeah.
of the government agencies have those things. It's only that the shift has to be done.
Yeah.
The boat is already.
They're trying to modernize most of it, but
That's what
is
I'm
it
saying.
that?
Yeah,
Yeah.
yeah. So that's what I'm saying. The boat is already ready. The new boat is already ready, but there are no people there. There are no people. There's no driver who can drive it. There's no people who can work on the boat and all that stuff. So the
Yeah, it's
intent is
basically
there.
sensitive or classified information, right? That's the reason. If it's like, I know banking has the, like information, but just in general, like for example,
Yeah.
the taxpayer data or the social security, anything that you see, right? So how can they protect all the, like keeping everything in place? Like you can't, it can't be that like seamless or like transparency, you know what I mean? Like
Agree.
they have to think. Yeah, that's the reason
Agree.
I was just curious. And that's the motto behind learning this aspect as well, because I'm already working, so I just don't know how the shift is gonna go forward. So yeah.
Yeah, shift is going to come because there's a lot of push, this time
Right.
there's
Right.
the government
Yeah.
also, I'm not sure if you're hearing, there's a lot of cost cuts into the external
Yeah.
payments, and there's a lot of shift towards, in-house development. That is
Right.
going to come this year, next year. So it's only us preparing for that and then keeping
Yeah.
ourselves ready. We're already in
Right.
government, if not in the vendor locked situation, then it's very, very good for you to equip yourself and then be ready for that wave. That's what I can.
Yeah.
Um,
Yeah. We'll see. I mean, how things go. It's yeah, but definitely this is gonna be helpful, like to leverage some of the expertise. So yeah.
yeah.
Thank
Yeah.
you so much, though. That's all I have.
All right, then I think if you don't have any questions, if you have any individual questions, probably I would request you guys to reach out to the course coordinators. We have Lakshmi in the group. You can reach out to Career IT; they will help you. Even if you have any other further questions, please reach out to them. They will let me know. Uh, Tomorrow, day after, we will be having sessions. We'll have similar sessions. Please bear with this time. This is not like I'll be spending 2 hours giving gyan on this. In the first few sessions, there will be a lot of these doubts. Slowly, as we solidify our understanding, get ourselves mentally prepared that I have to listen to this guy for next 2 months. Then slowly, we'll end up having more focused sessions. Okay. Thank you very much for your patience. And then I'm hoping to see you tomorrow. Thank you very much and take care.
Thank you.
Thank you so much.
Thank you.